Hello everybody, let's go ahead and get started with day 4, unit 3 notes. Today we're going to talk about function notation and intercepts. Yeah, that's what they are. Function notation and intercepts. So, let's just go ahead and dive right in. Independent variable is the variable that provides the input values of a function, so the x values. And dependent variable is a variable that provides the output values of the function, the y values. So you guys might have been familiar with function machines last year, where function machines are basically like what do you do to the x, the input, so that you can get that y, the output. Okay, so that's what we're going to focus on today, is like the equation that we use to generate our outputs from a certain endpoint. Now we use function notation, which is this f of x, and then we always write like equals whatever we have to do to x. So what that means is basically that's acting like that's your y value. Okay, so it's the same thing as your y value. Whenever you see f of x, it's telling you this is what you're going to get when you put in this specific x into the function. Okay, and we read it as f of x. You can replace it with the y if that's easier for you. That's totally fine, but you just need to be aware that when you see f of x, they're talking about the y, and when you see just a normal x, they're talking about the x value. Okay, so here's an example. We need to make a table for each function, identify the range of each function. So here we have y equals 5x. So, and they gave us a domain of 1, 2, 3. 0, 1, 2, and 3. So what we're going to do is we're basically going to take these x values, which is our domain, and we plug them into the equation, and what comes out is what the y value is. So that way we can make our ordered pairs if we need to, we can figure out the range, all this fun stuff, okay? So we're going to make a table, and in the first column we're going to make the x's, so 0, 1, 2, and 3. And the last column we're going to put our y's when we figure them out. In the middle is where we're going to use that equation to do our work. Okay, so for each one of these x's, we're just multiplying it by 5, and that's going to equal the y value for it. So I'm just going to go ahead and plug and chug. 5 times 0 gives me 0, so that y value is 0. 1 times 5 gives me 5, so the y value is 5. So the ordered pair I could write as 1, 5. Then I do the 2, so 5 times 2, the y value is 10, and 5 times 3 gives me 15, so the y value is 15. So this is actually my range now, 0, 5, 10, and 15. Okay? You guys are going to try this one on your own. I'm just making a table so that you can see everything. Alright? Okay. Moving on to the next one. Basically the same thing. But now we're going to go a little bit deeper into it. Use the table to find the range, and then plot the points on the graph. Okay, so they gave us the x values. Again, we're going to plug these x values in here and get our y values. So whenever we see f of x, it means it's our y values. What it means is that, like, the reason it's called a function of x is because this is what happened, like, when you put it into the function with this certain x value. So this is the result you get when you use this x, is what f of x means. Okay? So I'm going to go ahead and plug this stuff in. -1 goes in for x, so -1 plus 1 gives me 0. 0 plus 1 gives me 1. 1 plus 1 gives me 2. And 2 plus 1 gives me 3. Alright, so I got to plot these points. I think this stuff's going to pop up, yeah. Alright. Plot my points. I just want the points. I don't want this line. I'll move it. There you go. So I plot my points. And what actually happens is that when we connect the points, it makes a line. So a lot of the times when we get the equation, what happens is that we can go ahead and plug any x value. So we're talking about our domain being all real numbers. And we could possibly get out any y value. So a lot of times you're going to see them actually, when you have an equation, you can connect the dots because you can pick any of those x values in between those points, and it would make that function or line or curve or whatever it is. So now that we have our graph of a line, and I have to put arrows on it because it can keep growing, We ask, is this a relation? Yeah, it's still a set of ordered number or ordered pairs. Is this relation specifically a function? Yeah, it'll pass the vertical line test, and none of the x's are repeating. So, and it's also called function notation, right? Alright, so next example. This time we're given the range, and we need to find the x values, okay, the domain for it. So, they gave us the y values, the f of x. We're going to plug that stuff in for the f of x part here and solve for the x. So we're not plugging in for x, we're plugging in for f of x. So I'm going to make my tables same way. This one's my y, here are my x's, and here's the equation. I just changed the 1/2 to a fraction, or to a decimal, because I was typing it. You're more than welcome to use a fraction or decimal. Okay, this one's really nice and easy to switch. So now I'm going to go ahead and plug and check. Here are my y values. -9, -8.5, -8, and -7. So I'm going to plug it in for the y right here. So it's -9 equals 0.5x minus 8. So I need to solve for x. So I would add 8 to both sides. I get -1. Divide by 0.5. It actually comes out to be -2. Okay, do the same thing for the next one. Plug in -8.5. Add 8 to both sides and divide by 0.5. You get -1. Plug in -8 for it and solve for x. Add 8 to both sides, divide by 0.5, you get 0. Okay? And then last one, plug in -7 equals all this fun stuff. Add 8 to both sides, you get 1. Divide by 0.5, you get 2, positive 2. So those are my x values, and that's what I would fill in the table with. Okay? So you're going to try these two on your own. Okay? I was just making a table off to the side so you can do your work, but you're just going to try those on your own. Okay? Now, x-intercepts are the points where the function crosses the x-axis. Okay? And y-intercepts are the points where the function crosses the y-axis. So here, I don't know why I gave you a graph actually. It's important to understand how they're written, because once you understand how the ordered pair is written for an intercept, you can use that information to find a missing value. Okay? So x-intercepts are always written with a value for x, and the y is always 0, because you're talking about something on this line. Well, the y is going to be the same no matter what. It's going to be 0 here. So that is good to know, because if you know what the y is, you could solve for the x and find the intercept, the x-intercept. For the y value is what you normally have to fill in, and the x value is always 0. So again, here is where you'd find the x-intercepts. On this line, this is when the x value is 0. So y-intercepts are written 0, comma, whatever the value is for y, and x-intercepts are x, or whatever the value is for x, comma, 0. Okay? Now, x-intercepts also have other names that you're going to hear a lot, okay? Zero, solution, sometimes people just call them intercept, and they mean the x-intercept, but you're not going to hear that word as often. Another word you're going to hear is root. Ooh, that's not how you spell it. Root, so please fill this in. Okay? All of these things just mean the x-intercept, not the y-intercept. So if you hear someone ask for the zeros, they're asking for the x-intercepts. If you hear someone ask for the solution to the function, they're talking about the x-intercepts. The roots of the function, x-intercepts. Okay? The only way they'll ever ask you about the y-intercept is specifically asking, what is the y-intercept? Okay? So now, this example, they're asking you, what are the intercepts? So the x-intercepts and the y-intercepts. So I don't really like this word, so if you can cross that out, intercept for this synonym, I don't like it. When they ask the intercepts, they're asking for x and y. They're also asking, is it a function? Well, looking at the graph, you can probably tell it already is a function because it passes the vertical line test. So now we need to figure out our x and y intercepts. So x-intercept is going to be on the x-axis, and it's where it's crossing. So it's crossing right here, not at the -8. On the axis, it's crossing right here, which is -7. So to write that, I would write -7, comma, 0. The y-intercept is crossing right here at the 6. So your y-intercept is 0, 6. You should have a value for your y, for a y-intercept, and then 0 is just for the x. Okay? And then we said, yes, it is a function. Okay? And next one. So this one you guys are going to try on your own. Give me what the x and y intercept of this graph is. Alright? And if it's a function or not. Alright? And then our next examples are just asking what are the zeros. Okay? The zeros mean we're just looking for the x-intercept. Alright, so this one, we're just looking for where it's crossing x-axis. It's crossing right here. Now the only difference between zeros and intercept, like x-intercept, is intercepts are always given as a ordered pair. Where zeros, we kind of just write it out. It's 5. It's crossing the x-axis at 5. That is the zeros. Because we already kind of named that there's going to be a 0 at the end. That's why it's called a 0. So you could just write it as 5. Okay? That's the number we're crossing it as. And again, yes, this is a function because it passes the vertical line test. Okay? 0 is 5. Yes, it's a function. So try this one on your own. Woo! Moving a lot of things, huh? Try this one on your own. Now I'm going to give you a hint. There are 2 zeros because it's crossing at 2 different locations. And it kind of looks like it's not crossing at the exact number, so just round it. Remember, you're writing them not as ordered pairs, but as just a number. And tell if it's a function or not. And then the last... Oh, that's it. That's all we got. Cool. So, that's it for the video. It's kind of sparse, I know. Well, not too sparse. It was 11 minutes. So, if you have any questions, write it down, and we will answer them next class. But other than that, you guys have a great day. Okay? Bye!